for SoA, that they have this specific way that they set this fixed rate. So let's see how it is for SoA. Okay, so this is the SoA syllabus. So we have a set payments of variable interest, and we want to swap for a level fixed interest rate payments. Okay, so the example is follows. So we have this variable swap payment, C1, C2, and C3. And C1, C2, and C3 is based on a notional amount times variable rate. So C2 also a notional amount times variable rate. Notional amount is like the principal amount lah. We saw example before, right? Rate times a notional amount. So let's say $1 million. So this is the notional amount. So C3 also the same. A notional amount times a variable rate. So the variable rate technically is the rate at the swap time. So at time 1, what is the variable rate? So time 2, what is the variable rate? Swap time 3 is the variable rate. However, when we want to set our fixed rate in the beginning, we want to have a educated guess. We want to estimate what will be the variable rate that we will be paying based on the information that we have at the time that we set at the beginning of this swap. Okay, so this is technically like a educated estimation of the future variable rate. So we use forward rates. Okay, so QI represent the notional amount, right? Bear in mind, even though the notional amount is constant, C1, C2, C3 will still vary because of the varying interest rate lah. Okay. So the forward rates will be derived based on the yield curve, because forward rates we can derive from the spot rates, right? The R1, R2, and R3. From R1, R2, and R3, we can estimate our forward rates. Okay, let's see what is the assumption under the SoA syllabus. What is the assumption when they want to set the fixed swap rate? Fixed swap rate. They call it R, the level swap rate. So this is the assumption that they are using when they want to set the swap rate. So the present value of the payment based on variable rate have to be equal to the present value of the payment based on the level swap rate. So, but this based on variable rate, as we said, we will only know the actual variable rate when the time of the swap will come, right? But at the time of setup, we want to give an educated guess of the present value of the variable rate using forward rates. So, the first equation, this is the present value of the payments of the based on variable rate with the educated guess of the forward rates. And then this equation will be the present value of the payment based on the level swap rate. So this is still an unknown. R is still an unknown, but we want to solve for this R with this equation. So from this equation, we can rearrange and come up with this equation to solve for R. So R, based on this assumption, R will be the sum of all of the notional amount times the forward rate times the present value. PT is the present value. So if this is, we are talking about the first swap payment, so the PT will be V1. If this, we are talking about the swap payment that is paid on the second year, so this PT will be V2, and so on. And the denominator will be as follows: Q times P. Okay, let's see an example of the question. So, a 3-year interest swap has a notional amount of 200 in the first year, 370 in the second year, and 500 in the third year. So, you can just imagine it as follows lah. You can just imagine that this person have this liability, 200 in the first year. So, at the beginning of the first year, they have 200. At the beginning of the second year, they have 370. And in the beginning of the third year, they have 500 loan. So they need to pay off this. They are actually bound to pay a variable interest rate. And the variable interest rate usually is whatever the variable interest rate, the 1 year interest rate of the current market lah. So for the first year, they know for sure what is the variable rate already. But for the second year and for the third year, they don't know yet because it will reset based on the market situation. However, when they want to set this R, they have to estimate these two rates, with forward rates, right? Now we want to determine what is the fixed rate R based on the assumption that the present value of the fixed rate is equals to the present value of the interest payment based on variable rate, like this that I showed earlier. Okay, so how do we do it? First, we need to determine the forward rates first based on the spot rates that we are given. So the first one is easy. Forward rate for the first one is just same with the first 1 year spot rate. For the second one, it will be 1 plus R2 squared over 1 plus R1 plus R1 minus 1. So that will be the first forward rate. And then this one, 1 plus R3 to the power of 3 over 1 plus R2 to the power of 2 minus 1. Minus 1. That will be our second forward rate. Okay, once we know our forward rates, we need to find our R. So this will be based on the formula that we derived before, this one. Okay, and this formula is just rearranged from this assumption. So the formula will be the sum of all of the three. So we have three sums right now. So it is the sum of the Q times the forward rate times the present value over the Q times present value. So they don't have the F for the denominator. So it will be, for the first one, we will have the first notional amount 200 times our first F, which is 3%, times our P. So the first present value is 1 over 1 plus R1, okay, which is 3% in this case. R1 is 3%, and then plus the second notional amount 370 times the F12, this one, which we already calculated, times 1 over 1 plus R2 to the power of 2. Okay, plus the third notional amount 500 times the F, which is this one, times the P, which is 1 over 1 plus R3 to the power of 3. Okay, divide by same like above, but you just remove the F. So you just times with 200 over 1 plus R1 plus 370 over 1 plus R2 to the power of 2 plus 500 divided by 1 plus R3 to the power of 3. Okay, so once you calculate everything, all of this, you get your R. This is a special formula when our notional amount is constant, is level. So when the notional amount is level, the steps that you need to do for the working is going to be a bit shorter. Okay, because the Q above and the Q below will cancel off. That's the idea. So this is the proving. This is not really the proving lah. I just do one example if there is two swap payment, first year and second year. So if you go through this, then you can see the equation will cancel out a lot and end up being very simple. So what this means is this n is going to be how many swap payments are you going to have. So if you're going to have 2, then this will be the P2. So this one is 1 over 1 plus R to squared, 1 over 1 plus R2 to the power of 2, right? Yeah, so this is going to be the V for our last swap payment. If the last swap payment happened at time 2, yeah, then it will be V to the power of 2. Okay, so that is that. And this one is just the sum of all of the present value factor. So if you have 2, then you will have present value factor for the first and net swap payment, and plus the present value factor for the second net swap payment. If you have more, then accordingly lah. If you have 4, then you will do P plus P3 plus P4. Okay, let's try an example. A 4-year interest rate swap has a notional amount of 200 throughout the period. So first year is 200, second 200, third and fourth. Okay. Each variable rate is 1 year spot rate at the beginning of the settlement period. Okay, so it's just saying that the variable rate is dependent on the spot rate that resets every year. So determine the swap rate. Okay, this one is determined at the level swap rate R. Okay, as we said, we will use the assumption that the present value of the interest payment based on variable is equals to the present value of the interest payment based on the fixed, right? So because this one is the level notional amount, we will try to apply the formula that we just learned, the simple formula. So it will be 1 minus, so there will be 4 notional amount. So this one will be the present value 4 divided by present value 1 plus present value 2 plus present value 3 plus present value 4. Present value 4. Okay. The notional amount we don't even have to write because it will cancel out. The numerator and the denominator, it will cancel out. So it will just be 1 minus 1 over, this one will be 1 over 1.047 to the power of 4. And then divide by 1 over 1.031 plus 1 over 1.038 to the power of 2 plus 1 over 1.043 to the power of 3 plus 1 over 1.047 to the power of 4, dependent on this table. So then by doing this, you will get your swap rate. Okay. There's another special formula for a deferred swap rate with a constant Q. So this one, there is a deferment of the swap rate. For example, okay, this is the total year involved is 4. But the net swap payment, there will be 1 net swap payment here and the second net swap payment here. The first year and the second year, there's no. So there is a deferment. Okay, so if there is a deferment, the formula will be different. It will be, this is the discount factor for the deferred period. Okay, not the first payment, the deferred period. So the deferred period is 2. So you have to do P2 minus P, N is, when is the timing of the last payment. So the last payment, the timing, it happens at time 4. So P4. So N is not the number of payment, okay? It is the timing of the last payment. Okay, so it will be P4 divided by I means the present value of how many payments you make. So now you have 2 payments only. So the timing of the first payment and the timing of the second payment. So the timing of the first payment is at time 3. And then the timing of the second payment is time 4. So you know, TI. TI means the timing of the first payment and then the timing of the second payment. This one is the timing of the nth payment, the last payment. So it's like this. This one is the timing of how this is the timing of the period that doesn't have payment. So PT0. 0 means the timing of the period that doesn't have payment. So this one is 2. So that's why it's 2 here. Okay, don't be confused with these notations. Huh? Okay. Once you write this all down, you will get your R. Okay. So again, I reiterate the condition to use this simple formula would be 1, it is deferred. 1, the Q have to be constant. If Q is not constant, even though it's deferred, you will have to follow the long formula in the beginning just now. QF times P over QP. You have to follow the long way. This, okay. So let's do an exercise for the deferred swap. Wally enters into a deferred swap. He wants to swap floating interest rate for a fixed interest rate during the second, third, and fourth year. So, no swapping for the first year. The level notional amount is 5,000 each. So, it's level, okay? Determine the deferred swap rate. So, how? You are given the P1, P2, P3, P4 right away, so we don't need to derive. So it's going to be a lot easier. So let's do this. So the first one will be how many deferred period that we have. So we have one deferred period. That is the time that we don't have any payment, PT0. So it will be 1 minus the timing of the last net swap payment. So the timing for the last net swap payment is the fourth, P4, divide by the timing of the first net swap payment and the timing for the second and the timing for the third. So it's this one, P2 plus P3 plus P4. Be careful, not the count. If the count, maybe you will do P1, P2, P3, but no, it should be the timing. So R is going to be as follows. Okay. So this one is just a recap. So there are 3 different formulas that can be used to compute the swap rate. And again, remember, this is given the assumption that the net present value for fixed interest rate payment is equals to the net present value for the variable interest rate payment. But this is not the only way, but the SoA, they use this way, okay? Okay, so there is 3 formula. First is the normal varying Q. This one is if our notional amount is flat, so we use the flat one. And then this one is if it's flat and also deferred. So there's 3. So when you have a question, you have to analyze which formula you can use.